In a hall filled with 4,000 insect specialists from around the world, the biggest crowd wasn't standing around a professor. It was standing around a 10-year-old boy explaining his own experiment to grown-up researchers. His name is Joe Nagai, and he's the first person in the world to prove that a butterfly remembers what it learned as a caterpillar. Before him, this had only been seen in moths and never passed a single generation. And it all started with a question only a child would ask. Do the butterflies I raised remember me? He got his answer, and then he asked a second question, one that nobody had ever asked before him. Most kids who fall in love with insects want to catch them. Joe wanted to understand them, and everything that followed grew out of that difference. His first butterfly died. The caterpillar he picked up back in kindergarten couldn't get out of its chrysalis properly, and he later said he still remembers how much it upset him. The next year, he tried again, saw it through, and wrote down every single day, from the first leaf the caterpillar ate to the moment the butterfly came out of the chrysalis. He called the notebook, My 35 Days with a Butterfly. He wasn't building an insect collection. He was keeping records, and that's exactly why he noticed something everyone else walked right past. The butterflies he raised himself didn't always fly away when he released them. Some of them would circle him first and only then take off, and the ones he caught in the wild never did that. So he asked the kind of question grown-ups don't ask, because they already know the answer. What if they remember me? There was just one problem. A caterpillar and a butterfly are one and the same animal, and yet they have almost nothing in common. Inside the chrysalis, the caterpillar's body is taken apart and put back together from scratch. Picture a house being completely rebuilt. The rooms are moved, the wiring is rerouted, the old doors are sealed up and new ones are cut. And yet a note hidden somewhere inside stays exactly where it was. The caterpillar's memory would have to be that note. Muscles, sense organs, digestion, all of it changes. But the brain doesn't vanish completely. It's rebuilt so thoroughly that until recently, nobody knew what kind of memory could possibly survive it. In 2008, a team at Georgetown University showed that something does survive. They trained tobacco hornworm caterpillars to avoid a certain smell by pairing it with a mild electric shock. Those caterpillars then pupated, and what came out were adult hawk moths, and they still avoided that same smell. The work made headlines all over the world, and then everything stopped. One species of moth, a lab full of specialized equipment, a single generation of insects. Nobody went any further. Not that team, not other labs. Not one adult researcher for the next 14 years. In the spring of 2022, Martha Weiss, the same Georgetown researcher who had spent 20 years studying insect memory, found a large envelope in her mailbox at the university. Inside were 4 handwritten pages in careful English. Hello, my name is Joe Nagai. I live in Kobe, Japan, and I am in 2nd grade. When I found your paper on the internet, I was so happy. He'd known English since he was little. His mother teaches the language. They'd spoken it at home since he was in preschool, and he read science in American school textbooks. He went on to say he had been studying swallowtails for the past 3 years. Those are large butterflies with tails on their hind wings, completely ordinary in Japan, the kind you'll see in any city garden. The swallowtails he raised remembered him, he wrote, because they circled him when he let them go. Grown-ups had told him that was impossible and ridiculous. With the letter came photos of his caterpillars and 2 pages of charts. Weiss loved the letter, and at the same time she didn't believe for a moment that a 2nd grader could repeat her experiment. In her reply, she gently suggested something easier, like teaching butterflies to tell colors apart. That would make a great 3rd grade project. She figured that would be the end of it. But a few weeks later, an answer came back. I really want to prove that my butterflies can remember what they learned as caterpillars. I don't want to give up now. I really need your help. Joe hadn't waited for her permission. He was already running that experiment at home with whatever he had lying around. And he had a question for her, the kind you don't expect from an 8-year-old. Why had she used ethyl acetate of all things. That's the chemical entomologists use to kill insects. Couldn't the caterpillars be afraid of it on their own, without any training at all? Weiss later admitted she felt a little defensive about that. And in that same moment, she understood the boy was serious. Everything that came next, he did in a room of about 130 square feet. Inside it stood a mesh butterfly tent his mother had sewn for him. And by summer, the caterpillar containers didn't fit in the room anymore and spilled out into the hallway and the entryway. Every caterpillar has to be kept on its own. And at the height of the season, there were up to 100 of them. The experiment itself is simple. Joe would let a caterpillar smell lavender and at that exact second deliver a mild shock. Without the smell, there was never a shock. He repeated it day after day until the caterpillar started connecting the two. If it smells like lavender, something unpleasant is coming. Half the caterpillars went through this training. The other half got nothing at all and served as the control group, where a professional lab has a calibrated device for delivering shocks. Joe had a muscle stimulator from the family medicine cabinet, the same one he used on his own shoulder with 15 power settings. He started at the lowest setting and went up one at a time until he saw a clear reaction. At the fourth, the caterpillar pushed out its osmeterium, the orange forked horns that come out when it's frightened. The fourth is where he stopped, and he'd put the electrode pad on his own forearm with the caterpillar between the pad and his skin, which meant he took every shock right along with it. When somebody asked why he hadn't turned the power up higher just to be sure, he said that was enough for her. And then he added a line that tells you more about him than any award. I think of her as a friend, but I shock her, so from her side, I'm a bad friend. That left the question of how to test the adult butterflies later. First, he tried running the test right inside the tent. He set out 2 feeders of sugar water, added lavender to one of them, and watched which one the butterflies flew to. The results were inconsistent, and the whole setup had to go. So he set about building a Y maze, a clear tube with a fork in it where the animal picks which way to go on its own. He glued it together out of a plastic file sleeve he bought at a 100-yen store. The first version didn't work. The air moved unevenly through the 2 arms and the data from it was useless. He took it apart and started over and did that several times until the airflow evened out. While he was rebuilding the maze, the caterpillars in both groups formed their chrysalises. Now, all he could do was wait. A few weeks later, the butterflies started coming out, and Joe began sending them into the maze, one at a time. One arm had sugar water in it. The other had sugar water with lavender. The control group went first, the ones he had never taught anything. They split right down the middle, half one way, half the other. Then came the ones that had met lavender back when they were caterpillars. If the transformation wiped everything clean, these should have behaved exactly the same way. More than 70% avoided the lavender. Nothing was left of the caterpillar in them. Not the jaws it chewed leaves with, not the legs it crawled on, not the body that took the shock. They had been rebuilt from the ground up, and the link between that smell and danger was still intact. That fall, Joe wrote to Weiss to say the work was finished, and he attached his report. 33 pages. This is where the story could have ended, and for the professor at Georgetown University, this is exactly where it did. For the 8-year-old boy, it was only starting. The following spring, he sent Weiss another letter, and the most important part sat in the middle of it, tucked in among the everyday news, and it sounded completely casual. By the way, this summer, I would like to find out whether memory is passed on to the next generation. What he meant was this. He was setting out to test whether something a caterpillar had experienced could outlive not just the transformation, but the butterfly itself. Weiss later said one sentence that explains everything that came after. It never even occurred to me to ask that question. To test it, he had to do something that's hard even for a professional lab. Get offspring from the trained butterflies, raise them all the way to adults, and then raise one more generation after that. It sounds simple. In practice, it's 1.5 years of work, where almost everything comes down to luck. Butterflies don't mate on a schedule, and if the male and the female are ready on different days, there's no offspring, and the season is already gone. And if a virus gets into a container, a whole brood can die overnight. In the evening, you've got 100 live caterpillars, and by morning, almost nothing is moving. One of the world's leading butterfly specialists put it plainly: running 3 generations and mating the butterflies yourself is exceptionally difficult work, even for an adult researcher. Joe saw it through at 9 years old. The new generation got nothing at all. No lavender, no shocks, not a single day of training. These caterpillars simply grew, formed their chrysalises, and came out as butterflies. And for a lot of them, the day of the test was the first time they had ever smelled lavender. Joe sent them into the very same maze, where by every calculation they should have split evenly. Instead, most of them went down the clean arm. So he raised one more generation, the grandchildren of the butterflies he had trained himself. And the same thing happened again. The trained parents, 71%. Their children, 65. The grandchildren, 60. And wild butterflies that had never been through any of it, 51%, which means they were picking at random. These aren't random jumps. They're steady steps going down one after another, a trace that gets weaker with every generation, but is still there. The parents' experience reached butterflies that had never lived through it themselves. In the summer of 2024, Joe invited Vice to Japan, to the Congress that had accepted his presentation, and she flew out with her whole family. They rode a cable car up into the mountains, caught beetles. He showed her his favorite castle, and she gave him a hand lens on a string, the same kind she wears around her own neck. And it was only on the last morning of the Congress that she told him there was something they needed to do. Over 2 years of letters, Weiss had checked his methods, helped him write up his abstract, and flown halfway around the world to watch him present. But she had never once opened his raw records. She simply didn't know whether they would hold up. Joe and his mother brought the binder to her hotel room, and they went through it page by page, running all the numbers twice. And then Weiss took out a 10-yen coin. She explained that they were about to check whether the butterflies could have been choosing at random, and she asked him to flip the coin 10 times. It came up 5 heads and 5 tails, exactly what you'd expect when both sides are the same. And what if the same side had come up 10 times in a row? What would you think? She asked. That the coin is heavier on one side, he said. Then they ran the same kind of test on his butterflies. The number they got came out past the point where chance stops being an explanation. Weiss looked at him and said, "Something really did happen to those butterflies." 2 days earlier, Joe had been standing in a big hall where hundreds of printed studies were hung up in rows, each one with its author next to it, ready to answer questions. He had printed his own research on a sheet just like everyone else's and stood beside it, in a suit, with business cards. This Congress meets once every 4 years and is considered the biggest event in world entomology. Those 4,000 researchers had come to Kyoto that August from 82 countries. First one person stopped in front of him, then a second. By midday, people were standing several rows deep, and Joe himself was no longer visible behind them. Adult entomologists asked to have their picture taken with him and told him he had a big future. But here's the more interesting part. They came over to look at a kid with a piece of paper, and they stayed to discuss his results. That same specialist who called his work exceptionally difficult said one more thing about him, that he'd like to take this boy into his own lab. And on the first day of the Congress, Joe was invited to present his research to the Crown Prince of Japan, separately at a private meeting. Joe doesn't know yet exactly what passed from the trained butterflies to their children and grandchildren, and that's the next job, a far bigger one. Maybe the offspring really do remember something, or maybe they're simply born with a sharper nose for that particular smell. But even that second explanation would mean that one generation's experience changes the next, and nobody had ever shown that in butterflies before him. He's betting on epigenetics. Genes are what's written into a cell from birth, and you can't rewrite them. But a cell doesn't read all of them. Some genes are switched on and some are switched off. And this is where experience comes in, because it can switch genes on and off inside the cell. The genes themselves stay exactly as they were. In worms, this mechanism has already been found. In butterflies, it's a schoolboy from Kobe who's looking for it. After the Congress, the boy decided on his own that he didn't have enough data to publish in a scientific journal, and he expanded the study to nearly 400 butterflies. Over 6 years, about 1,500 butterflies have passed through his room, and he raised every one of them himself. From egg to caterpillar, from caterpillar to chrysalis, from chrysalis to a run through the maze, alone in his own room, between school and homework. In 2026, this work took the top prize at a national competition, the Prime Minister's Award of Japan. And before that, Joe represented Kobe for 5 years, running at a nationwide research competition for kids. He's supported by the Masayoshi Son Foundation, a program for the children Japan considers its most gifted. It pays for his equipment, his books, and his trips to international conferences. At a University of Florida seminar, he gave a lecture on memory in butterflies and moths, as the second speaker after Martha Weiss, on equal footing with her. And right now, he and researchers in America are getting the next experiment ready. This time, not on swallowtails, but on monarchs, the butterflies that fly thousands of miles to a place they have never been and find it without a single mistake. Joe wants to check whether the same mechanism is at work there. It all began with a boy wanting to know whether his butterflies remembered him. Today, an American university is working on that question alongside him. He's already preparing his next talk for the World Entomology Congress in Cape Town. And after that, he plans to carry all of this over into medicine, because if experience can switch genes on and off, then one day it could be used to treat both people and animals. And this is only the beginning for someone who hasn't even finished school. He's 12 years old.